Okay, today we are going to talk about roots and fractional exponents. And this first thing is just something to memorize. So if I have a root, the square root, I'm going to do it in a different color. We never bother to write this, but there's an implied 2 there on the square root up in the upper corner. You don't write it, so that's where this, what's called the root index here, becomes the denominator of the fraction. Sometimes this is easier than doing roots on your calculator. Just do it as exponents with a fraction. The fifth root is then x to the 1/5. Well, if I have the cube root of x squared, that is x to the 2/3. I can show this with my exponent rules as x squared to the 1/3. It also works the same if I do it this way. X to the 1/3 squared. When I multiply my exponents, I get x to the 2/3. Sometimes this is useful. Well, the cube root is 64. What cubed is 64? That's 4. Sometimes I can do this like 8 to the 2/3. Sometimes it's nice to do it as roots squared. The cube root of 8 is 2. 2 squared is 4. Usually it's easiest to do the root first. So 8 to the 2/3 power is 4. It's not 8 times 2/3. It's very easy to make that mistake, but it's 8 to the power of 2/3, which actually means this. Okay. So we've got a couple of different forms of these. We have, sometimes we will convert to exponential form. And if you can simplify an exponential form, like my 8 to the 2/3, let's do another one. So to convert this is an exponential form. It has something to an exponent. It's called a rational exponent. Rational is a ratio of two numbers, aka a fraction. So rational means fractions. So I'm going to start with my root. This is in radical form. Sure, I could write it like this, but that's going to be harder to simplify. I don't want to cube 81 and then try to take the fourth root. What I'd prefer to do here is take the fourth root of 81, which is 3. So square root of 81 is 9, square root of that. Square root twice is equivalent. So the square root of the square root. And that is 81 to the 1/2. It's the inside one. And then 81 to the 1/2 to the 1/2. If I multiply those exponents, 81 to the 1/4, which is the fourth root. Okay, these are all equivalent forms. So 81 to the square root was, square root of 81 is 9, square root of 9 is 3. So that's how I knew the fourth root of 81 was 3. Now I've got 3 cubed. That's not 9, that's 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. If it wants you to write it in radical form, most of the ones on your worksheet will not simplify out like this, but you should simplify it. If it's numbers, you should simplify it as much as possible. If it's fractions, well, you can't. Or if it's not fractions, variables. So sometimes we'll need to convert to radical form. So I'm going to have a root. And I put my whole thing, my numerator goes either inside or outside. I prefer to put it inside if I can, unless I can simplify the numbers, which I'm not going to be able to on this. I put it inside. So the cube root, I need to square both parts, the 7 and the x. So 7 squared is 49, x squared. And that is in radical form. Well, the negative exponents tell me I move it to the denominator. Now I will do my root. Five to the fifth. It's kind of a big number. I maybe should have used something. 625 times 5. I think this is 31.5. I got it. 5 to the power of 5. Yes, 31.5. I would expect you to use a calculator. If the numbers get to be into the millions, you can leave them as something like 5 to the fifth. But that's small enough that you should be able to do it. And this is in radical form. Okay? We'll put some things back into exponential form. I don't want that. Here's some new ones. That was a fractional one. Let's put it in, I'm gonna start with a radical. Oops, not what I wanted. There we go. This is a K. So 1 over 3 to the 1/4 K to the 2/4. I'm going to move them to the numerator as negatives. So I can do this. I can flip them top to bottom by switching the sign on the exponent. And I'm also going to reduce 2/4 to -1/2. So I can go from radical to exponential. I can go from exponential to radical, as you see in the box right here. Okay, we can go both ways. Sometimes we will have to apply some of our exponent rules as well. Okay. So the first rule I need to do is apply this -1/7 power to both of them. When I apply it to the end of the 21st times -1/7, I must multiply. Now, step 2, I'm going to make them positive exponents, which means I'm moving both of these to the denominator. 128 to the 1/7 power, or the 7th root of 128, you're going to use a calculator, and that's going to be 2. If it doesn't work out to be nice with your calculator, try it, but if it doesn't work out to be nice, you don't use it. Okay, n cubed. How to enter that into a calculator? Most of the calculators use this caret, some of them use an XY. You must, however, put unless it shows it on your calculator as an exponent, raised up like this one, which a lot of the graphing calculators do, but most of the scientifics do not. You need to put these parentheses around it. I want everybody to check with their calculator right now at the end of this video that this equals 2. If you did not get 2, you did not enter it correctly. Please ask a neighbor how to do this, okay? Because I don't want people getting them wrong because they didn't know how to enter it on their calculator. Okay, that is the end of the lesson on rational exponents.